Thank you very much.
Thank you.
Yeah, thank you very much for the kind introduction. I'm Siegfried, and this is my colleague Stefan. And we are both from Germany, from a research institute called Fraunhofer SIT. And since this is our first time at Hack in the Box, we thought it might be a cool idea to bring some local beer to hang out together after the talk. So feel free to come on stage or meet us out there and grab a free beer. Thank you. Cool. So let's start with this talk. Well, let's introduce us a little bit. Stefan, would you say a few words about yourself?
Yeah, as Siegfried already mentioned, I'm Stefan. I'm a mobile researcher working also at the Fraunhofer Institute, and we together are members of a small student hacking group, and as you can see, we're enjoying our spare time to teach students a bit of hacking, and here we want to present some of the results.
Yeah, thank you. Yeah, I'm Siegfried. I'm a malware and vulnerability researcher at the Institute. My main research focuses on static and dynamic code analysis, so combining these two guys together in order to automatically identify vulnerabilities or to spot malicious parts in software. Yeah, but this talk is not only about us, as Stefan already mentioned, it's about our team. So we founded a hacking team at our institute consisting of us and a couple of students, and we meet up in our spare time and hang out, have a beer and pizza, and then we look into interesting topics, and this password manager was one of the topics we looked into. So the credits also don't only go to us, it's go to these brilliant students I mentioned here, and yeah. Good, so let's start with the motivation. I guess you all, when you look at this slide, there are different icons, and you probably have an account for this, for instance, for Apple, YouTube, Skype, or whatever. And well, you're all aware we're in the security area, and it's hard to remember all these different passwords. So, well, it's usually not a good idea to have a single password for all of the accounts, and it's also not a good idea to have a password like blah, blah, blah 1, blah, blah, blah 2 for the different accounts. So, well, you have to remember all these passwords. And there was an interesting study showing that on average, 90 different accounts, an average user has 90 different accounts, and you have to remember all the 90 different accounts, credentials, which is a hard problem. So, so the community came up with different approaches to solve this problem. Well, on the top of this line, which goes a little bit away from remembering the passwords to whatever public key crypto. There's other approaches like biometric authentication or picture authentication, where you remember a couple of pictures or some parts in the picture, and this lets you authenticate against their account. Well, but it turned out that there's probably a lot more in the research area, but somehow we still stick to the problem of remembering these passwords. So this goes down to the line, to the notebook, because I see in my personal environment always, especially for girls, they have a paper notebook and they're writing down their passwords in the paper notebook, like in whatever, in page 153, between two addresses, they hide the password. Well, if you do this for 90 accounts and you have to reset, it's probably also not a good idea. And this brings me finally to our talk, the password managers. Well, it's in general a cool idea. So you have a password manager where you put all your credentials, and then you have a very long master password. And once entering this master password, you can access all your sensitive credentials for it. And basically, we talk about this. So we thought in the group, well, it might be a cool idea to look into password managers. So as a first step, we looked on the web. And we checked out different vendors, what they think about password manager and how they promote their password manager. And we found one interesting vendor saying, yeah, so we use AES 256, a very strong encryption scheme. And while our password manager is basically banking level or military grade. So it's like, wow, cool, right? Let's give it a try. And we say, challenge accepted. Let's look into these guys if it's really so hard to break them. So, well, when we thought about this the first time, we thought about this picture. So, well, you have a street here, and you can have a barrier with your 2056 encryption scheme, but there is always a left and a right to basically go around this thing. And, well, it turned out that this was most of the time the case in our vulnerabilities, what we found. So as a first step, well, since we focus on Android applications because mobile is cool and password managers, so we checked out a couple of password managers on the web. So we download only the most downloaded ones because they are the most interesting ones. So for instance, we ordered by their download rate a Keeper, KeepSafe, 1Pass, and so on and so forth. So we collected 9 of them. So the first question which probably comes into your mind, why isn't there X or Y password? Why didn't you look into X or Y? We got this question quite often. And well, there is no special reason. So as I said, we are sitting together, we downloaded 9 different password managers, and then we started looking into the 9 in order to find vulnerabilities. And it turned out that we found a vulnerability in one of them, in each of them, at least one. And then at some time, well, we got bored and we said, well, let's stop this project and continue to another project. So there's no special reason why we didn't look into another one. And I also want to state that this is not a complete pen test. So it might be the case there are more vulnerabilities in it. We only basically looked in it and we identified a few of them. Good, so let's talk a little bit about the core features or the features we identified by looking into these apps because they are interesting for the talk. So while there is confidential password storage, well, with the master password, which I already explained, then there is this great feature of a secure synchronization, because if you have 2 devices or a PC and a device, and you would like to add whatever credentials in your whatever Android device, it should be synchronized with the PC, so you should also be able to log into your PC. Another thing, again, for user convenience, autofilling. So once you open, for instance, a Twitter application, it should be automatically and magically fills in your credentials because the user is lazy and he wants this. Also a great idea. Another thing is a custom browser. We saw a lot of applications that implement their own browser and they integrate it into their app due to various implementation reasons, which we will explain later in the talk. And the last feature, which is basically, well, they said, well, remembering this very long master password, it's probably hard for a user. Let's give them also a chance to remember a small PIN, and this is basically similar to the master password. And we will also say a few words about this later. Good, so this slide shows an overview about the different interactions which are important for the following talk. It's not complete, but it is enough for explaining our vulnerabilities. So this box here symbolizes the smartphone, and this box basically is the password manager app which sits in its sandbox, in the Android sandbox. And what we found that most of the password manager apps store their master password in a file which is in a sandbox, which is usually okay. It's encrypted, sometimes not. We will mention this in a second. Database, so the credentials, or the account credentials, what you enter are also stored at a database in your sandbox. This is, well, for convenient, I edited plain text, but usually they're encrypted, sometimes not. Anyway, and so there is another connection to, out of this sandbox, there's an account manager, which is special in Android, and some apps store the master password there. We will also explain this later on. There's what I already mentioned, there's a connection to the internet due to the synchronization problem, or due to the synchronization feature, sorry. And then, well, for instance, if you have a Twitter application, for instance, this app, there's also communication, obviously, between the password manager app and this app to automatically fill in the credentials. And last but not least, there's a PC which can also communicate with the smartphone, which I'll explain in a second. Good, so no root scenario. What do I mean by this? All our attacks we considered are based on no rooted devices, because if the device is rooted, a few things are broken, because basically the sandbox model is broken and you can easily access the file and the user names and the password, while you have to decrypt it, but most of the time the key is inside the app, so it's not a big issue to decrypt the master password and so on. So all our attacks we mentioned are based on no rooted devices. Good, so let's talk a little bit about a few attack vectors, which we'll explain. First attack vector is the scenario, so you basically found a device which has a password manager on it, and you're able to log into the device. And then is it possible, once you plug it into your PC and connect to the device, is it possible to extract, for instance, the secured master password or the database files, which should be protected. First attack vector. Second one, what happens if I sit in between the master password and the internet? Is it possible to intercept or to get the credentials? Third one, well, if I somehow intercept the communication between these two apps, is it possible to get it? And last but not least, if I'm able to install an additional application on your device, is it possible that this additional application accesses or gets the master password and the credentials? So these are the four different attack vectors what we looked into. Well, in this talk we will not cover all of them because due to time restrictions, but in total we found 26 different vulnerabilities. And in the following, we will explain 5 in more detail. And later on, we give an overview what kind of vendors we attacked, or what kind of vendors, what kind of issues we found in them. Okay, so let's start with the first scenario. So basically intercepting the communication between these two guys with the attack vector that you basically install an additional application. So is it possible to access it? For this scenario, I will explain 2 different kind of attacks. First is manual filling, so manually filling the credentials from the password manager app into your Twitter application, for instance, and automatically filling, so I will explain this in a second. Manually filling. So the scenario is like this. You have your password manager app on the left, and you have your Twitter application, for instance, and these are the credentials of the Twitter. What you do as a user, you do a right click, you do a copy on the password manager, and then you, for instance, click on the password, do a right click, and you paste it. So it's general stuff. How does it work in Android? Well, you have a clipboard, and most of the password manager apps made use of the clipboard. So they store it on the, once you copy it, they store it on a clipboard, or save it on a clipboard, and then they read it from the clipboard. Well, when we look at this, we probably already see what's the problem. The problem is that in Android, every application can read from the clipboard without any permission. So this means you can write an application, and once you copy something to the clipboard, you can read it, and here we go. And that's basically the problem, and in most of the apps we looked into, basically they had all the same problem. Well, I would say even worse, because there are also some benign applications that make use of the clipboard functionality due to internal functionality of the app, which has nothing to do with this. So it might be the case that there are already applications out there that copy data from the clipboard and send it to the internet, and basically they steal your data without any purpose, basically. Second scenario, since this manual copying is not cool for the user, right? He wants to be more, it should be more convenient, so let's automatically fill the credentials. So how does this work? So you basically open your Twitter application, and it should be magically insert your credentials because you're too lazy to do a right click and a left click and again. But how does it work in Android? Because in Android, these two applications run in its own sandbox. So it's usually not possible to put something in a field in another application or vice versa. So it's usually not possible. So how do they do this? Well, the one possibility is a so-called accessibility service, which I'll explain in a second. So an accessibility service, so you have your password manager application, and you add an additional service, a so-called accessibility service. And this service is integrated into your app. And for instance, once you open the Twitter application and you click on the password field, it automatically triggers a callback in the accessibility service saying, hey, now the user clicked on the password in this app, and you can also fill or add some data into it. So why is this the case? Because I said it's usually not possible. So I have a quote from the Android developers saying, yeah, so this accessibility service is an application that provides a user interface enhancement to assist users with disabilities. Now it makes more sense, right? And users who are driving, taking care of a young child, and very loud party. So I really like the last one here. But yeah, so it makes sense. So they come up with this accessibility service due to people with disabilities to make it easier for them to interact with the app. But when we read this, everything fits perfectly to the password manager apps, right? No, obviously not. So they basically abuse this thing and make use of it. But the big question is now, so we now know that it's possible to identify fields in another application, but how do you know automatically that these credentials, for instance, should be passed into the Twitter application? So Twitter, for instance, has com.twitter.android as a package name, a unique identification of the app. So how do you do this? Well, they thought some application password manager might be a cool idea. Let's look into this a little bit. When you add a new password credentials, where you add the name and you add the website, twitter.com, username and password. And there is the Twitter application which starts with com.twitter.android, right? So they thought, cool, right? So there is a connection between this URL and the package name. So let's make use of this. So what they did is, they parse basically at twitter.com, then they reverse it to twitter.com, then they check it if it matches with com.twitter, with com.twitter. All right, that's okay. With com.twitter, and then it checks if the current activity has a text password field in it, and if this is the case, it automatically injects the credentials. So it looks good, right? But what happens if they only check for the prefix? So they only check for com.twitter and not an equals. So this means I can come up with an application, for instance, com.twitter.twitterleaks, com.twitter.hackinabox, whatever. I write an application with a password field in it, I open it, and it magically inserts the credentials of Twitter. And for this, we also have a demo, a short demo. Oh yeah, demo time. Okay, so this is the demo. Well, there's the device. I run it now. So now we open this password manager application. We enter our super secure master password, obviously, to unlock our safe. There is our Twitter credentials, well, random credentials. You can use them, they don't work. And now we see that we will add this super cool feature of automatically filling the credentials. For this, we have to register the accessibility service. It's in the settings, this activate autofill, you see it here. Well, it adds the master password, and now it says, yeah, you need to register the accessibility service. Now we are basically in Android. In Android, you have to explicitly register this guy, the accessibility service, which is a good thing. Now you're enabling the accessibility service, and now Android is saying, hey, dude, are you sure? Because Avast wants to observe your actions and retrieve your window content. And the user says, yeah, obviously, yes, because I would like to have this autofill feature. And he clicks on OK. And then it says, well, we go back. And now it says, yeah, now you're good, and everything works perfect. So that's it, and what we do as a next step, we open our application, because this is now really fast, so we will click on this application, which is our fake com.twitter.twitterleaks application, and what we see here, when we click on it, it immediately inserts the credentials. So this means it accesses the username, the password, and just that you see it, this is a dot notation, so we added the real password here. So this shows basically you can come up with an application and it will automatically insert it. This is only for demo purpose. We also wrote an application which is completely transparent, so you don't see that anything is entered. It basically runs in the background, and we can steal the credentials from you. Just if you click on an application, it shows the credentials, then you go back, and then you open a game or whatever. So we showed that this shows that it's possible. Now let's switch. Good, and now we'll hand over to Stefan, who will continue with the rest of our text.
Okay. Yeah. Siegfried already introduced our attacker models. The next attack I want to show is so-called evil mate attack. Just assume you lost your device or someone found it, or steals your device and is able to bypass your screen lock, some swipe pattern, whatever, and he can connect your device to the PC. Is it possible to read out somehow the protected password database, password container, or just get the master password? And for this scenario, I'd first introduce some Android function. I don't know, is everybody aware of the Android debug bridge? So I don't have to go in detail with the debug bridge. Oh, that's great. Okay, everybody knows also, if I have access to the device, I can enable this developer function. And the cool thing is, Android debug also allows the so-called backup function. This means if the application has the backup feature enabled, I can make a backup of the target package. And the backup is considering the whole private data folder. So let's say everything what is in the sandbox can be backupped when this backup flag is enabled. After the backup, there are tools just to transform the backup into an archive. We can extract it, and there we, for instance, found an XML file containing the master password or master secret in plain text. That was the whole protection. And the idea is this app will not really require any backup flag because it has a back-end synchronization. They do their own backups. But this is one very easy way to bypass the sandbox. And as you can see, the master password is there in plain text. Just make a cat and you have full access to the encrypted password container. The next attack scenario is considering more on the app side. So I can, for instance, trick the user to install a malicious app, or when I steal the phone, can install a malicious app or whatever. So the idea is just to bring an app on the target device. And before I explain the attack in detail, I want to make a short side note. I think everybody knows the browser problem here. On Android, we have a lot of different browser types, and as I already mentioned, or Siegfried explained, we have our password manager app. And now the idea of the password manager is somehow to also enable this auto login feature for the browsers. So how can we fill the login or the password post form automatically in different browsers? The best solution would be when we have each browser provides some common API which we can use to inject our content. But the problem is there is no such API. So the developer of such password manager apps come out with a new idea. What about if we build our own browser? So here we see we have our password manager app, and now they built their own browser. The problem is that the own browser is part of the application. So this means the browser is running in the same process as the application and is also part of the same sandbox. The advantage now is because the browser is part of the application, the password manager completely can control this browser. So you can see the autofill is, for instance, working. But the question is now, can we abuse this browser somehow to bypass the sandboxing and access the local app folder to get, for instance, stored credentials, master password, and whatever? So at first, a few details about the browser. How are they designed? As I already mentioned, they are part of the app, so they are running in the same process, so they are part of the sandbox. The most browsers use the WebView API, and a special feature of the WebView API is it supports also file URIs. You have to disable or enable them. What happens now if the file URI support is enabled? You will see it here. Imagine this is our browser bar, and now we enter some URL. We know the package name, we know the data folder, the package folder. We know also some XML file name of the application because we could reverse engineer or analyze it. And when we enter this in the browser, the app listens all the sandbox content. Here you see a more sophisticated XML file. For instance, the XML values and attributes are obfuscated just by an MD5. And what you can see here is our master password or our PIN. It's here base 64 encrypted, so we cannot read it, but it's also really encrypted with an additional key. The question is now, for decrypting the master password, we need the key. And where can we get this key? This is very easy. We just look into the code, because the key is hard-coded in the application. This one here is a more sophisticated. They have obfuscated the key by splitting it up in two parts, but we found different other password managers who had just a complete string, which they use as encryption key. So as you saw, we get access to the WebView, so we could read out the stored master password, use the encryption key, the algorithm, and decrypt the master password. So another attack, as Siegfried also mentioned, now we get access to the master password files or database. But there's also, we found one application who thought, okay, we make it a more bit sophisticated. We put it in the account manager. What is the account manager? The account manager is some centralized class provided by Android. It's based on a simple SQLite database, and it's restricted with system permission. This means no application can access this database directly. For writing, reading, or interacting with this database, Google especially offers a special API, and each app can use this API. Despite of the using, there's still separation, because it cannot be that application A can read out something from application B. Here is also a short citation from the Google developer website, which really says you shouldn't pass the user actual password to the account manager. You just should use some special token. So to sum this up, don't store your master password or your credentials in the account manager. Guess what happens? I'll show a short demo. Then after that, I will explain the demo in details, because I think there will be then a few questions. Okay, so you see again our smartphone. At first, we start the application. I logged in with my secure master password. So, as you could see, the password was very complex and hard to remember. I activate some convenient option. It's called the pin lock code. So I can set a pin lock, so I don't have to remember to this complex password. And they also offer me to somehow store the master password to get access again when something happens. So the remember function here in the corner is activated. So when I start now the application, you will see my new PIN is working. 1, 2, 3, 4. So I can also use the PIN instead of the master password. Everything is fine. Okay, now you see in this corner a short script which is accessing this central database I already mentioned. Here. Okay, a few explanations. As I mentioned, the attack is working without root. Now you think I'm cheating because you need root access to this, but this root access is just for you to show or to get access to this database that you see. Okay, where is it? Here. Our application stores somehow encrypted and encoded the database, the master password in the database. So when you now continue, I install my attacker app, and the attack is based on a so-called residue attack. So after installing the application, you see this is just for demo purpose, and with this application, I can also register an account where I store my information in the account manager. You see here, I will explain it in a few minutes. Here suddenly happens some exception. This is the output of an exception, UID, something went wrong. Now when we continue, what I'm doing now, I'm uninstalling our target application. So you saw this dash line, I was configuring, setting my master password, everything, and now I'm installing it. And what now I can do, I click on extract the password. As you can see here, my application here shows now the same as on the left side. And when I click on decrypt, I could decrypt it. The question is now, okay, I have extracted it somehow. Why could I also decrypt it? The same solution as before. Password is the key, the encryption key is part of the application. Okay, what's now the secret behind this attack? So here again you see the Android system, our account manager API, our account database. So now when we install an application and the application wants to store some information in this database, it needs a so-called account type. You can imagine this account type as some kind of primary key for the database. So the data are stored in the database. Also Android stores the UID, so it knows, okay, for this UID and this kind of primary key, this stored information are associated. Now we see our attacker app. Our attacker app defines the same account type as our target application. When you want to install it, you saw there is a collision. This was the exception you saw in the demo, because the UID, Android recognized, okay, the UID is not matching, it's already blocked, you cannot access this information. But what happens now if we uninstall the dash line? The Android system says, okay, I remove it, but give me a moment, there is someone who still is using this primary key. They do not check the UID, they just check the primary key and say, okay, I cannot remove this information because there's still some application which has registered this primary key. And now we just simply can access and read out this information from this system database. And this is completely working without any root access or something. Here you saw just the code excerpt. It's just a few lines. You saw you build a new instance of the account, some email address. This is the account type or mentioned. This is primary key, catch the exception. And this is just the reading out. You identify your account again by the account type and get all your information. So just a few lines of code. I was testing this code or this exploit on Android version 6 or Android M. I don't know if it's already fixed on Android 7, but I had no newer device. So now these were all demos. I just wanted to list a few further, let's say, fails or critical weaknesses we found in different password managers. The first one is just custom crypto. I don't know, the developer thought AES is not so good. I'm more sophisticated. I built my own crypto. It was based on just some XOR or character flipping. So you can imagine broken by design. Some used AES, but in ECB mode. And the problem is, if you use it for database, use the ECB mode, imagine you store your passwords and some users have for 2 or 3 servers the same password. This means with the ECB mode, each password is encrypted the same way. If now an attacker somehow gets or breaks one password, he can also derive the other passwords from the other services. Also, a very funny thing is the self-implemented browsers I show you do not handle or consider subdomains. This means if you store credentials, for instance, for the page mypage.wordpress.com, you can store the credentials. But then if you go to phishing.wordpress.com, he automatically also fills the credential in such a post form because he cannot determine or resolve the subdomains. The browsers also had data leakage problems, enforced HTTP traffic, or use Google search just in plain text. And one application also, we did not show it in detail, but they also did not rely on HTTPS or TLS. They implemented their own crypto transport protocol, and as the custom crypto, this protocol was also broken by design, and it could be possible just to man in the middle and eavesdrop the protocol and sniff the complete password container synchronization to the backend. Just a short slide with a few recommendations and improvements to the password developers. Android provides a key store. In the newer version, it's also combined with hardware system or TPM module. So if you want to store credentials, the secret master password, why ever, put it in the key store. There it's better, but the overall recommendation is don't store the master password. When you do crypto, don't put any string in the application. Do some key stretching or key derivation. The Android API provides the PBKDF2 function. It's not the fastest, but for instance, Facebook also offers a good crypto library. It's called Conceal. They also offer PBKDF2. It's around, I think, 1,000 times faster and also uses a more secure hash algorithm than the Android API, but do key stretching. Avoid hard-coded keys. I think I don't have to say anymore. And when you're using AES, for instance, database encryption or file encryption, use a good crypto mode like CBC and GCM. And do not abuse the account manager. So here you see now a list or an overview of all findings. As you see, this was the table from the beginning, the different password managers. Here again, the different weaknesses and vulnerability we found. The first one was the master pin. So in this line, in all these apps with across, we were able to somehow get and decrypt the stored master password. These apps had hard-coded keys. There we were able to somehow bypass the sandbox without any root. These were different side channel attacks like clipboard sniffing or some other derivation. Here, these apps had self-implemented browser, which completely ignored subdomains. However, this browser had data leakage problem. One application just encrypted the password database only partially, so there was no full encryption. And this one was the broken synchronization, where the developer thought, okay, we can do it better than TLS. You see, we have a lot of crosses. We did not achieve a full bingo, but it was enough. All findings, advisories in detail, you can find here under this link, when we put all the security advisories which we sent to the manufacturer on our website. And we go to the end because the beer is getting warm. A short summary. So we showed several ways or techniques to attack the application without any roots. A few of them, or the most of them, were just possible because the application provides some convenience function, and this convenience or comfort function just weakens or destroys the complete security concept. And yeah, as I already mentioned, all findings were reported under responsible disclosure, and I think nearly all, except one, are already fixed. So I can only say thank you for your attention. If you have any question, feel free to ask. If you are thirsty, take some beer.
Thank you very much. Well done for having the fastest applause of all the talks so far by just offering free beer. Any questions from the floor before we get to the beer? Oh, wow, I'm surprised. Yes, there is one.
Thank you for the talk. Have you encountered any password manager that tries to protect the data even despite root attacks? Because there are countermeasures that can do it.
Sorry, did you understand it?
Only partially.
Only
So
partially.
you were saying that they implemented some ways to circumvent our attacks?
No. Have you found any password manager that tries to protect its data even in the presence of a root access?
We found, not really protect, but there were, for instance, LastPass informs the user, he's made a small window and says, we recognize your device is rooted, please don't store the password. But then you say, okay, despite of this, I want to store it, you store it. But there's no really, let's say, active protection against rooting or, for instance, do not start the application or preventing password storing or whatever. Some recognize it, but it's then a user decision how to handle the warning.
And how good was the obfuscation, if there was any, on those products?
There were no really obfuscation. It was just the ProGuard shrinking shortening the name. But if you, for instance, whatever DexCard or some really hardening framework, there was no obfuscation. This was very easy. For instance, the demo, which stored I showed in the demo video, the dash line, they had the encryption part in native, but this is also just security by obscurity. So you can also reverse the native part. In this case, I have to say I was a bit too lazy. I just put the library in the application and used the static key.
Thank you.
Yeah.
Any other questions? Feel free to enjoy the... Oh, wait.
Which password manager you recommend to use is best from your analysis?
To be honest, I have a small self-written one where I can enter the password based on an XML file. It's encrypted and decrypted. No autofilling, nothing, no password remembering. Just use a bit of AES encryption and the XML file. But if you, for instance, the password manager we showed, when you disable all this convenience feature and don't store the master password, they should be secure. Use it just as a container. Don't use all this autofilling, shifting, storing, remembering, shortening features. Then it should be okay.
Thank you. Any further questions? No? Well, thank you very much, Sigrid and
thank you.
Stefan. Thank you.